This video covers classification of metal ions by chemical properties. We will determine a number of chemical properties of a collection of metal ions and use that data to determine a possible classification scheme.
Go to your reagent tray right here and then take the magnesium metal bottle out. Place a piece of magnesium metal pieces like this, all right? Just one piece to each test tube, okay? And if you add too many, that's fine too. It's not crucial, but at least one piece, all right? So, whoops. And sometimes it's a large piece, sometimes it's a small piece, but it doesn't matter. And then you can see the shiny, beautiful, shiny, silvery looking piece.
Once you have added magnesium metal to all the 11 test tubes, add about 10 drops of each metal cation solution separately to these test tubes. For example, right now we are adding barium ion solution. And in the next test tube, we will just add copper 2 ion solution, then chromium ion, and so on and so forth. Wait at least 10 minutes to record your observations.
Copper 2, and then chromium 3. Okay, and if you add two drops too many or 2 drops too less, that's fine too. So that will be 1, 2, 3, 1, 2, 3, 1, 2, 4. Beautiful. And then we'll have a potassium 1, 5. Let me first just take it down and then. Okay, and then we'll have a cobalt 2. 1, 2. All right, beautiful. And then give a gentle stir, and then now we just want to see if there's any reaction occurred, all right? And all of us know if color of the solution changed or color of the metal changed, and then that indicate a new material is formed, right? And we want to see. Now it's a sodium. It's 1, 2, 3, 2, 3. Beautiful. And then we have a strontium ion, and beautiful. And this one will be manganese. And then the next one will be the calcium. All right, last but not least, it's our good friend iron 3. Beautiful. Okay, and then we done. And then just give a shake. Beautiful, right? And then today we pay no attention to the bubbles, all right? That's because some of the number one, solution is acidic. And number two, magnesium actually reacts with our water. And then so you will form a magnesium oxide, and then beautiful. And then, all right, so today we only pay attention to the color of the solution and the color of the metal, all right? So very well, beautiful. So now you may want to see this. For example, our clear sky blue solution, now it's green. Now you can see. And then that beautiful shining silvery, so silver metal, look, our magnesium, now it's dark. All right, so that indicates there is a chemical reaction, and our silvery metal looking magnesium remain as a silvery metal looking, and then color of the solution remain as a clear colorless. That indicates something, all right? And then this one, it's a little bit hard to see. However, if we have a better light, and then you can actually see the metal pieces, and then there is a deposit like the molds growing on top. It's very hard to see this. That's because of the concentration of our chromium 3, all right? And so on and so forth. And so we just generated this, and then next one should be our nickel 2. Before was a beautiful green, and then now still green. However, the color of the intensity of it, and then it's already started diminishing it. And then you also see there's some kind of a deposit, that silvery looking surface, now it's tarnished. And then so that indicated there is a reaction going. All right, so that's all. And pay no attention to the bubbles, all right? Pay no attention to the bubbles, and but you can see the surface of our metal pieces. It's no longer just silvery and clean-looking metal magnesium. It's all now getting darker, all right? It's getting darker, and so.
During the mixing of two different chemicals, you have to observe the three visual indicators of a chemical reaction: change in color, formation of precipitate, and or formation of effervescence. For page 48, you will just record if there was a reaction or no reaction between magnesium and the metal cation solution. We will now proceed to step B of this exploration. If you compare the reaction sheet and compare the table on page 49, we see that the column of reaction with ammonia is missing on this sheet. This is because ammonia has a very pungent smell. Hence, we will perform reactions with ammonia in a test tube. You will add 1 drop of the metal cation solution in one tube and 2 drops of ammonia.
And finally, we have our good friend iron 3. All right, now you are told add 2 drops of ammonia to each example 2. I think steak. Beautiful. Okay, very good. After all the addition, and then just give a gentle shake, 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 and gentle shake, and gentle shake, gentle shake.
For reactions with ammonia, record on page 49 if there was a reaction or no reaction. But unlike with magnesium, you have to be specific if during the reaction there was just color change or a color change along with precipitate formation.
For example, our copper 2 ion, it's no longer sky blue, you can see, no longer clear colorless, and then now we have this very, very deep royal blue color formed, all right? And then you can see for our chromium 3, no longer this deep violet blue and change to this cream and off-white color, but also the PPT formation. These two, not only color changed, but also PPT formation, all right? You can see right here, oops. Yeah, right here, all right? The PPT formation. And for our iron 3, not only color changed, but also PPT. You can see, all right, the PPT formation. It's orange, no longer yellow, all right?